Algebraic proofs. Algebraic proofs are in the process of getting us ready for geometric proofs. So we're going to walk through this using skills you already know to write a proof. Here's the basic setup of a proof. For a two-column proof, you need to set up a t-chart. Here's the little t. And on the left, there's going to be true statements. In this case, algebraic statements. With geometric proofs, you'll have more geometric algebraic or geometric and or algebraic statements over here. For the reasons, you'll have the rules and why you did the things you did for the algebra. So for example, distributive property, addition property, that's adding the same thing to both sides. Subtraction property of equality would be subtracting the same thing from both sides. The rules that you've done and maybe didn't know the names of those rules or haven't been reminded of them in a while. Geometric proofs, the rules are basically write the statements over here and write the reasons over here. It is the same for algebraic proofs. You're going to start with the given and you're going to make a step-by-step path to get to where you're trying to get to, but you have to state the rule. That's the only difference between algebraic proofs and just algebra. Algebra, you just do the steps and sometimes they come automatically. But with an algebraic proof, you do the steps and say why. Do a step, say why. Do a step, say why. That's all the differences. So let's do one. So example 1, to do an algebraic proof, sometimes for some people, it actually helps to do the math first. So if I were to do this problem, and I'm going to do step by step, I might distribute first. And so you think, okay, I'm distributing, so that means using the distributive property. That would be the rule. Okay, and then you do the next step and you're like, okay, what did I do? Oh, here was the original and I distributed. Okay, so that's just my step of what I did after. After that, I'm adding 3x to both sides because it's a negative 3x. So you want to do the inverse operation, the opposite, or whatever undoes that. So negative 3x, the opposite, or what undoes minus 3x, is adding 3x to both sides. When you are adding the same things to both sides of the equation, it's addition property of equality. And then it just gives the results. And then I'm moving this 10. So I'm subtracting 10 from both sides, which is the subtraction property of equality. Keep going. This is just once you've done that. And so I have 8x. Whenever I have something alone touching the x, touching means multiplication. So I need to undo that by dividing. And so dividing by 8, dividing on both sides, division property of equality. And then here's my simplified version. So if I start with this and I'm trying to prove that x equals negative 2, if you're just thinking algebra, you are given the problem and the answer. So here's the problem and here's the answer. In algebra, sometimes your teacher would just look, oh, you got the answer right, you're good. But in geometry or algebraic proofs, writing proofs, you need to start with what's given, go all the way down through all the work, and end with what you're trying to prove, step by step, with a reason for each. So I'm going to cover this up. Well, I'm just going to move this, actually. I'm going to take the statements. So the first step, we have to start with what's given, just like a regular proof. So I started with the problem. 5 times the quantity, x plus 2, equals negative 3x minus 6. So here is the problem. It is given. And as I slide this down, the next step, notice it doesn't show my work, or like the little arrows that say, hey, I distributed. It just gives the results. So in a proof, in an algebraic proof, in a geometric proof, you don't actually show all the work. Like you don't show subtracting on both sides. You just give the next step as if you did. So here's my next step, 5x and 10. Okay, I use the distributive property. So right here, notice you added 3x to both sides, but I'm not showing that. I just give the result. So again, with algebraic or geometric proofs, you do the next step, but you don't always show the steps, or rarely. You rarely show the steps. Some people in a different color right here might say, oh, I'm going to take this and I'm going to all right, next step. Look how the 10 was moved over here, subtracted 10 on both sides, but I don't show it. I just give the result, subtraction property of equality. And keep going. I divided by 8 on both sides. See, I showed my work, but I didn't show the step. I just give the result, division property of equality. So exactly the same math without all the showing, but you do have to give all the rules, all the reasons, the whole step of the way. Here's another one. I left a space for you on lesson, I believe it's actually 1.7, sorry. Example 2 on 1.7. Example 2 on 1.7. I gave a spot for you to do the math first. Just like we did on that last example, having the math there helped you know what steps to do next. So do the math. Give yourself some space. You can type it in. You can handwrite it on your paper, but do the math first. So I'm hoping you remember what you start a proof with. Should be the given. So I know I'm going to start with the given. If you look at this picture, I don't want to say picture, given. That doesn't tell us something. It doesn't tell us anything mathematical. You need to get something mathematical. So for sure the given, AC equals 19, that for sure is given. But look at this other information. That is given too. So you have to take the visual and try to break out things from the visual that show the math. So here's the math. Okay, AB equals x plus 18. So the length of AB, and it just uses the visual to write it down. So these are all given. Sometimes you have one given, sometimes you have multiple givens, and that's a total normal thing for geometric and algebraic proofs. And then the length of BC is also given. All right, so as a concept, I'm hoping you remember angle addition or segment addition, and you can add this segment AB plus this segment BC and get the total segment. Okay, to do that, just add them up. Take the two segments, add them together, and set them equal to the total. We know the total is 19. So I'm going to bring this down. AB plus BC equals AC. That's what I just discussed. Bring it down, segment addition. That's how you add segments together. You take the two parts to get the total. We already know what these numbers and symbols represent, the variables. Let's just plug them in. There's a name when you plug it in. It's substitution. I think you can see it though. Substitution. Okay, here's AB, here's BC, and there's the total. Okay, bring this down. If you're doing the math first, I think you can get it. Hopefully you know to combine like terms. And depending on the teacher, you might write this different ways. Some teachers call this simplifying. Some teachers call it combining like terms. So you find out from your teacher what they prefer, simplifying or simplify or combine like terms. Okay, so there it is. We combined the x and the 3x to get 4x, the 18 and the 25 to get 43. And I'm already showing the next step, but I'll bring this down anyway. 4x equals negative 24. That means this 43 was moved. It was subtracted from both sides, so that 43 was moved from both sides. And when you subtract 43 on both sides, it's the subtraction, to make it a little bit shorter, property of equality. So lots of teachers will accept subtraction, property of equality, written out like POE. Some teachers will not, so be aware of that. Make sure to ask your teacher if that is an acceptable way to write that rule. And the last step, x equals negative 6. So I'm hoping you can tell that they divided by 4 on both sides, which makes it the division property of equality. Okay, later on those slides, I'm going to just walk you through, but you are doing these on your own. So you're going to prove, I'm going to move this, you're going to prove these things by dragging and dropping, but everything is out of order. Luckily, I placed them on the right sides, so the statements go on the left, the rules and reasons go on the right. Another one, same idea, a little bit more steps. One more, but notice there are some blanks. So you're going to have to drag and drop and give your short answers. And I did leave some space for the math. Remember, if you don't want to write on the computer, just you can write on a piece of paper or on your workbook. And then I'm going to have you try one by yourself. So totally blank, Copy and paste as many boxes as you need or want to put in the statements and the reasons. And this is a great way to practice your skills to determine whether you are totally good at algebraic proofs, kind of okay, or really need some help. Okay, so hopefully this helps.